All right, so let's look at the final thing we have to do through the class, and that's the statistical analysis portion of the Otto's Auto Parts case. So we got the Otto's Auto Parts, and it's got this factory, and he's wants you to tell him some things. He's asked you to do three things. Step number one is to take a look at his workforce and tell him about the gender and the age of the workforce. Okay, that's the first job. So we go to the, there's a file out there in Canvas called Otto's Auto Parts Statistical Results, I think. And we go open it up, and then there's a list of names here, and you go down, find your name, and then find your code. Okay, this isn't a real one, obviously. The code that's been given to me by former students is 6666. So I go along here on the edge, and I find 6666, and then I get my data. That's my data. So copy it. Open a brand new Excel spreadsheet and drop it into it. Okay, I'd recommend not doing it in Excel. It depends, because we're going to use an app called Data Analysis, and it's not the exact same app on the PC, and different versions of it have slightly different versions of their app on Apple. So you may want to just do it at school or at work on a PC if one's available. Because the only problems we've ever had with it are people who try to do it on Apple. All right, so we got our data, okay, and then the next step is we take our data. Let me switch over to this one now. Okay, so now I got my data, and the first thing I need to do is to do a description of gender. So I go back to my data and say, how many males and how many females do we have? So you can do a quick sort if you want, or just count them 1, 2, 3, 4, 5, 6, 7, 8, 9. There are usually fewer females depending on your data set. So let's suppose we have 20 males and 14 females. So put male in cell A1, female cell A2, and 20 and 16 your counts there. Then grab that, click on Insert, go over here, click on Chart. The first one's fine. Grab that chart there. Okay, and we get that, and then we get that. Notice it doesn't have any numbers on it there. And then we go to Design, there it is, and click on one of those so we can see our numbers. Is there a question on that? No. All right, and the chart title, call it, workforce gender or something like that. Give it a title. So we see that 56% of those sampled are male, 44% are female. Those are your p-hats. And now I refer you to a couple of problems here. The very first version that I put out there had the wrong referrals. So unless you got one recently, or look at it, if you don't want to reprint it, and just, or the page, the problem numbers are right, but the page numbers were wrong, and the referrals of what to look up, things we've done to give you clues to how to do that part. So I say go look at page 25, number 2, and then page 24 to construct your confidence interval on gender. So we go to page 24, and here's how I will use this one to try to guess the P, the proportion of males or females, take a pick, that you're going to try and estimate that's in the population. The workforce of 800, I believe. And here's your you know, your 0.44 or your 0.56, and plug in that, get your number, and then make your statement. I'm 95% sure that the percentage of males or females in your population are between this and that. Okay. I've given you this little help thing out here for Excel if you want to use it. I've got the formulas built here for you, right? If you want to, but you got to plug your numbers in there. And I calculate the lower bound and the upper bound there. I just put this out this morning. It's called Lecture 10 Notes Auto. And so it's an Excel, Lecture 10 Excel Auto. Yeah.
Put the lower and upper bound in our note in our paper.
Oh, absolutely. Yeah. Yeah, I want you to say, first off, none of this stuff, well, the only two things we're going to cut and paste from Excel is this pie chart and the histogram. And then it's all going to be, you're going to explain in words what anything that's important in the Excel sheets, anything that's important there, explain it to Otto. So you're going to say something like, I took a sample of 36 out of your 800 employees and found that 56% were male, 44% were female. I'm 95% sure that the proportion of males or females is between this and this. You might also mention that it's a very wide margin because it's qualitative data and it's a small sample size. It's, you know, it's not really very accurate. All right, next thing, go back to our data. You always go back to the data before you do anything. The only problem students have had is they've been on one sheet and then try to run the next application, but you got to go back to where the data is every time. So I want to know about the descriptive statistics for age, and then I also want a histogram on age. So I'm going to verify that data analysis has been installed. So I click on data, and I see my data analysis option there. If you don't have that, then you click on the down arrow, click on more commands, add-ins. Okay, where's my add-in? I want the analysis tool pack. Click on analysis tool pack, click on OK, and it'll install it. If you don't find it there, then you did not buy a full version of Excel. And as students here, you get it free over the student store, right? It's all free. You get a free Excel and a free Word, I think. It used to be. Yeah, free. Free. Oh, okay. Well, yeah, it's free. So I say, okay, I'm going to run that. So I go click data analysis. I click on descriptive statistics. I click on, I say my data is for ages in C1 through C37. And I have a label in the first row. And I want to run summary statistics. And when I click OK, I click OK. I don't want to click OK. I click OK, what the heck. I get this result. Here's age, and here's all your descriptive statistics. Yeah, I got a better version of it here. Okay, then the next thing we're going to do is we're going to go back to the data, and we're going to run the histogram. So I go and I say data analysis, give me the histogram. This is a pretty good app. I want the C1 through C37. I leave the bin range open. Labels, give me the chart output. poof, and I get this little jewel here. All right, so don't call it bin, call it age. Give a title here, histogram of age. This also is pretty ugly along this axis here, right? So clean it up a little bit, get rid of all those zeros. Just, you know, bingo, there you go. Clean it up and make it look good. All for show. And then we get this one here. I didn't clean that one up, I should have. So here's our descriptive statistics. We are ready to write the paragraph on age. I took a sample of 36 of your employees in regards to age. I found that the average age of those sampled was 36.1 or 36.06. So, but don't go any more than 2 decimals, okay? Standard error, I have no idea what that is. Median, I know what that is. Half your employees that sampled were 33 years of age or less, half were 36 of age or more, 33 or more, and this is called the median. So when you don't give me a list of definitions and then define it as you use it and tell me what it is, just like that. 50% of your people have 33 or age sampled, 50% or more 33 age, and that is called the median. The most often seen age was 27. You have considerable diversity or variability or dispersion, some good nice words in there, in the age of your workforce as measured by something called the sample standard deviation, and your sample standard deviation is 14.0. That's all you need to do. Don't mention the variance. Kurtosis, I have no idea what that is. Skewness, okay, now we can talk about the histogram. This says we have a very significant positive skew. As you can see in the histogram, it is not symmetric. It is skewed to the right. That means that the mean is greater than the median. Tell him what it means. And it is unimodal, meaning it has one clear highest peak, highest frequency. The range is from 15 to 47. Hopefully the 15-year-old has a work permit. Yeah. The range is 15 to 62, a range of 47. Not too many old people working here. And a little lawsuit pending on age discrimination. All right, and then the last thing you do is you give me a confidence interval on the average age of the workforce. Okay, so we head back to our picture here, and you're going to be using this one right here. You're going to be using this average age of the workforce. Okay. So I need an X bar, I need an S, I need an N to do a confidence interval. Come on. Here's your X bar, there's your S, there's your N. So you take S over the square root of N, that's your step size, and Excel's already done it for you. This is S over the square root of N. That's what this is. That's what that term is. They've already done that for you. Okay. I mean, I did it by hand anyway, but this is S over the square root of N. Because they say, hey, when you're done, you might want to do a confidence interval. All right, so I take that and I say, take my X bar and I go 2 to the left, 2 to the right, and I'm I'm 95% sure that the average age of your workers is between 31.38 years of age and 70.73, with my best guess being your average age is 36.06. Section 1 is done. Any questions on section 1? on to section 2. Go back to our data. I create a new column called change here, okay? And performance change or just change. And here I put G2 minus F2. To get this value here, I put G2 minus F2. I say here was their performance without the computers, and here's their performance with the computers. We've been asked to evaluate the financial feasibility of getting these handheld computers in. They cost us some money, but the benefit is they might reduce, they might increase productivity and reduce the cost of production. So we did a test run. We got 36 people, trained them on the computers and tried them out, and we saw if their performance rating went up. These are performance ratings. How productive were they based on the performance rating? So this person went from a 95 to a 101, which went up 6 points. So I get that for the first one, and then of course drag it, get the little plus sign and drag it down, and we get that. Get them all. So most of the people went up. I mean, some of them went way up, you know. Got somebody lazy and is going to do most of the work for them. So, whoa, good, good. Got somebody there who went down. 62-year-old female. Okay. Maybe. No, that's not. It's just she might not be tech oriented. Okay. There's another one here. Ooh, 32-year-old male. Maybe from South Dakota, my home state. I don't know why that. Yeah, okay. I wasn't trying to be funny on either one of those. Now I do my descriptive statistic on that. And I go back, do a descriptive statistics. And I say, give me column H. And labels, summary, click, and then I get where'd that one go to? Hypothesis, there we go. And I get this. I get this one here. So on the average, our productivity went up 5 points. Median was 5, the mode was 6. Okay, here's my S. Here's my N. To do a hypothesis test, I need an X bar, an S, and an N. So I got my sample data. All right, so what kind of hypothesis test do I got to do? So we got this computer, handheld computers, and the economics is that they cost me 30 cents an hour to incorporate them into the business. The benefit is for each point of productivity that I increase, it drops me 10 cents of production cost. So I do a little cost benefit analysis. I take the benefit of 30 cents and I divide by the benefit of 30 cents and divide by the cost of 10 cents. And I see that productivity needs to go up 3 points to be cost effective. To cover our cost, it has to go up 3 points. Well, we think it's going to go up what? 5. So most of you are going to be right around 5. A little bit less, a little bit more, but right around 5. And you all are going to be able to reject HO, meaning you're going to say, get the handheld computers. Okay, and I refer you to page 34, number 9. Where did that one go? All right, do I have that one? Here he goes. There's a problem with a lot of similarities to what I'm asking you to do. Let's take a quick look at it. Apu has been promoted to purchasing manager for the entire 4,000 Quickie Marts. He's considering replacing the existing squishy machines with a new improved model. The amortized cost of the new machines is $10 per week per store. The machines will reduce the cost of a squishy by 5 cents per squishy. Apu will only invest in the machine if he's 95% certain he'll make a profit. Just like in your case, Otto will only invest in the handheld if he's 95% sure he'll make a profit. He took a random sample of 36 Quickie Marts and said, how many squishies did you sell last week? And the average was 212 with a sample standard deviation of 30. So you don't know much about the population here. We do know N is 36, X bar was 212, here was 30. In your case, N will be 36, your X bar is gonna be 5 or right around it, and your S is gonna be 3.6 or around there, okay? All right, the values you're gonna get right there. We're asked to prove that the new machine is profitable, just like you. This is your HA, is new machine, handheld computers will be profitable. And HO is that the new machines won't be profitable. Well, that's not how we run hypothesis tests. Hypothesis tests are run on mu's or p's. So what is the break even? $10 divided by 5 cents, cost divided by benefit. We got to sell 200 squishies to cover $10. If they do more than that, then we're going to make a profit during the week. So their HA is mu is greater than 200. Yours is mu, HA is mu is greater than 3. 3 for your case. You got it right here. Laid it out for you. Here you go. There's your case study. So you'll have the 3 here, 3 here. You're going to have 36 here, around 5 here, around 3.6 there. All right, and it turns out it's a case 1A3. Yours is also a 1A3. Z-test greater than 1 than Z1 minus alpha. Your alpha is 0.05, same as this. So we look up Z.95. You use 1.65 just like here. You plug in your values right there. And see, and you all will be greater than 1.65 when you do this calculation. If you're not, then email me, please. So you will be able to prove with 95% certainty that Otto is going to make a profit with the handheld computers and should implement them corporate-wide. Lastly, do the p-value. Plug it in here. Find out how to do the p-value. We look up the 2.40 standard deviations, get Z.9918, set it equal, solve, and we get the p-value is equal to 0.0028. So we say to Apu, there is only a 0.0082 chance that you will lose money by getting the new squishy machines. There is a 0.9918 chance that you're going to make money by adopting this proposal. Okay, and that's your begin your sentence. First sentence of that paragraph when you talk about the hypothesis testing. I used a powerful technique called hypothesis testing, and I guarantee you with 99.18% probability you're going to make a profit. It's a grabber sentence. And yours is higher than that. Any questions about it's step 2? Right. Onward, Excelsior. Oops, where am I? Okay, back to the data one more time, last section. All right, so everybody gonna recommend the handheld computers. So the last thing we're going to do is we have 2 screening devices that we put potential applicants through. We give them a general aptitude test and a manual dexterity test. And then, but we don't have any formalized procedures of what to do after that at the company. So we're going to help them out and tell them what to do. We're going to use their scores on the general aptitude and manual dexterity to predict job performance if hired. Predict the job performance if hired. And we're going to use the job performance with computers because we've already recommended that by the time we get to the section. So I do regression. I click on data, click on data analysis, click on regression. I say, I want to predict what? G. I want to predict productivity. G1 through G37. What variables do I want to use to predict it? D1 through E37. That grab me 2 variables, D and E. Click on labels. Okay. Click on OK, poof. You'll get your result. Your result may look like the following. Here's an example, one sample regression from the Nevada gaming case. When did that come from? From the Auto part. Good grief. Case. So you are given an output like this. You look at the p-values. Is everybody happy? Is everybody a player? Everybody's a player. All those p-values are below 0.05. This is good to go as is. Got that? About 1/3 of you are going to go with the equation with 2 tests in it. You're going to tell Otto, keep both tests. Both tests are significant in predicting performance. Others of you are going to have one or the other of the 2 are going to be above 0.05. They're going to drop. So 1/3 of you get this prototype. So follow 42 number 2 if you get this case, they're both significant. All right, what is our predicting equation? Our predicting equation is y hat equals 62 point whatever plus 0.14 times 10 to the opposite, but 0.14. Do not put a y hat anywhere in your report. Tell him what it is. Make it user-friendly. It is predicted performance if hired. This is predicted job performance if hired. They say, from now on, use both tests. Administer the test. Get your scores. Plug in your, use this equation. So give them the equation on a line by itself. And then say, for instance, our potential applicant stands still, got a 220 and a 190. Plug it in like so. So give them the basic equation and show them an example regarding standstill, how to use it. And you get your predicted performance of 110.9. Give them a confidence interval around it. 110.9 plus or minus, this one's a 68, so one of those. Tell it about the R squared. 68% of the variation in job performance is explained by knowing these test scores. And you are ready to figure out whether you want to hire them or not. Do we want to hire them or not? I don't know. Is a 110 good? On a scale of 1 to 100, it's really good. On a scale of 1 to 130, maybe not so good. So we don't know the scale yet. So let's find out. what's our current scale for productivity look like? Click on data, click on data analysis, run descriptive statistics, and run it on column G. Run it on column G. All right, and when we click OK and done, we get histogram regression performance. Yeah, performance is good. We got a 105. So do we want to hire Stan or not? Yeah, he's going to be considerably above average. Not just average, he's going to be above average. Was it 110 something? Okay. He's going to be above average. So, you know, if we're shorthanded at all, or if we expect anybody to any changeover in staff, then we'll hire him. So if he's right around 105, you say he'll be an average employee. If we need somebody, hire him. If not, you may want to wait a while. If he's way below, pass on him. If he's way above, say hire him immediately. Others of us will do regression, and we will see something like this problem here. Here's the problem in the Otto's Auto Part case. Look at our p-values and what's true. My brother-in-law suggested general aptitude score. Is it a significant predictor at all of performance? Absolutely not. There's a 77.2 chance. It doesn't tell you nothing. Okay. Question is, why didn't we just leave it in? Because it might help just a little bit. You get rid of noise factors, because he could do exceptionally well in general aptitude and it'd throw your whole forecast off. You get rid of anything that isn't significant, get rid of the noise. And it's not going to change, that isn't going to change anything to many decimal places in your accuracy. So what do we need to do? I need to go back and do regression again. I got to say, oh, my Y is in column G, and my X is only in column E. The E was the manual dexterity variable. Okay, so you eliminate one of them, and then you get an equation that looks like this. And this will be the prototype for about 2/3 of the people in class. You'll use page 43, number 4 as your guide for writing this section. Okay, if the applicant scored a 220 on the, we plug into our equation here, and we get that is going to be, under this circumstance, a 102.6. Exactly 102.6? No. 95%, 102.6 plus or minus 2 of that thing right there. Okay, are you going to hire him if he's a 102.6? No, not if the average employees are 105s. No, you pass on him. All right, so any questions at all on the paper itself? If you can get it done, before Sunday night, I'd appreciate it. Help me out a little bit with the grading I got to do, whatever.